Okay, so right now I'm working on var24, longest character replacement. I had mistakenly forgot to press record when I started this problem, so I have some thoughts already. As you can see, I've already solved this problem, but that was in the past. So yeah, let's take a look. This is example input I had earlier based off the one that they gave us in the problem. And I had a few insights with this example input. The first being that I'd initially thought that we're looking at one character, and we could have at most, one other character that we can replace. But yeah, I'm looking at it now and I realize that doesn't really make sense. But the letter chosen is still a valid criterion thing we should look at when we're going through this problem. So, for example, if we have this A, say our sliding window so far is just at this. Oh yeah, this is also a sliding window problem. I'm getting this based off of this problem right here from Rocking the Coding Interview. So we have the letter chosen. So let's say our sliding window starts at just A. Right now it's at AC. We have one replacement, and we could replace either C or A here. I really wish it was easier for me to change my colors. Here we go. So this could be either A, or this could be C. Okay. Now, take a look at here. Our sliding window is now at length 3. We could replace these two with A. These are all valid options. We could replace these two with C. And we could replace these two with B. Okay, now sliding window increases by 1. And I think now it started to become clear to me that the letter chosen is the letter with the most occurrences within that substring. So here we're allowed to also replace two of these letters. Yeah, so these would be A. Because K is equal to 2, I think K is equal to the number of letters not chosen. So A would be the ones here. Okay, let's continue this example because I want to see how the algorithm would work for the rest of this string. So we'll erase a few of these here, 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 here. B. So right now our substring is here, but what happens when we reach this is our substring? Well, right now, if we were to choose B, we would need 3 replacements. If we were to choose A, these are both our most frequent letters. We would also need 3 replacements. Therefore, we have to decrement the sliding window such that it only includes at most 2 other characters that are not the character we are choosing, and I think in this case it should be B. So we will decrement it to here. We see that now it's only 2 other characters, C and A. Okay, and then this is a valid string again. So we can extend our window. We see B is the same as our letter chosen, which is B because it's our most frequent letter. And then these two would be replaced. And then we get to here. We have 3 non-letter chosen characters. K is equal to 3. So we would decrement or adjust our sliding window such that this is our sliding window. And at this point, there is no more characters. So our algorithm would terminate and we'd return the length of the largest window we'd seen so far, which is this one or the previous one we'd seen with C and not A. That would have a length of 5. Okay, so now I have some sort of intuition, so I'm going to try to code up what I've seen so far. Timer is going. I started this a little early, but that's fine. So we want a left pointer for sure, which is the start of our sliding window. We want occurrences this will use to pick our most frequent letter. And do I might need to I might need to have just the most frequent letter chosen letter I would say, and maybe chosen count is equal to 0. I'm not sure if this is necessary yet, but I will keep this here because it seemed relevant for our drawing that we had. Other things we might need to keep track of. Max size is equal to 0 because will be our thing we're returning, and that's going to be the longest substring containing the same letter you can get after performing the above operations. Yeah, so let's do that. Total. Also want to do the total count, which is the total amount of actually I don't really need this because I was gonna say this is the total amount of the characters in our substring, but we don't really care about that. Well, we do care, but we can derive it with a different way. So equivalent to r minus l plus 1. This is our window size, and then minus chosen count. Yeah, this will be our total window size minus the occurrences of the chosen letter, and then that will be equal to the total number of non-chosen letters in our window. So we don't really need this. I'll keep this comment here just for remembering that. But let's try to write the for loop. For r in range length s. Okay. So we should definitely start off by getting hold on. We should definitely start off by getting the number of characters of this specific character in our substring. So chars is equal to I'm gonna choose a different name for this, maybe car map. Car map Could choose a more descriptive name, but gets the job done. I'll just also put this just for remembrance sake. Car occurrences in current window. Okay. So carmap.get sr, and in the case that we don't have any, we choose 0. Carmap.sr plus equals curcar plus 1. Okay. Now we need to separate our task into 2 steps. Which is finding the most frequent character in sliding window, and perhaps decrementing the sliding window if chosen count plus k is greater than r minus l plus 1. If chosen count plus k is greater than r minus l plus 1. Yeah, so r minus l plus 1 minus chosen count. This has to be less than or equal to k. Yeah. So if char plus 1 is greater than chosen count, then we have new chosen letter, which is chosen letter is equal to, I don't know if we actually even need this, now that I'm thinking about it. I'm gonna include it here anyway, and then I'll remove it afterwards if I need to. So chosen letter is equal to sr. I think we do. We might actually, because we have to increase our sliding window. We will see though. Okay, so chosen letter is equal to sr, and then chosen count is equal to char plus 1. Yeah, no, I'm just gonna do this. This is much more readable. So having a plus 1 everywhere, I just add it to over here. So while, so actually, if, no, while r minus l plus 1 minus chosen count, this is k. What do I want to do? So what's the easiest way to find the max? Because that's what I'm struggling with right now. the easiest way to find a max. The brute force way would just to be get each of the values in our current substring and iterate through it, which seems very inefficient. Let me think about this for a second. Yeah, we had to have a new way of getting the largest number of occurrences of any given letter in our substring. We need to check that when we decrement a character and it's the same as our chosen character. Let's see, so in this case of ACBA, because A in this example will be our chosen character, but then we decrement, and this is our new substring, because C is equal to, or K is equal to 3 here, so it needs to be equal to 2. I've realized that I need to change this around because if K was 3, this would represent, no, this would represent K being 3, and we want K to be less than or equal to K, this K. Our other option is a heap, but that's log n every single time. Log n. I might do this. The same example, because once we get to here, we see that the count of B is equal to the count of A. I'm going to rewrite this string in a different way just to see if this example works in both cases. So we also have, let's say A, no, let's say B, C, B, A, that would work. B, C, A, A, CX, A, X, A, B. Okay, so if we reach here, this becomes, yeah, if we reach here, I don't think this would work, because once we reach this B, it becomes, again, our chosen letter. But once you start decrementing the window, run through the same issue again. So yeah, that doesn't really do much of anything. just trying to think if right now if there's another solution that's comes to mind rather than taking the max of cur map dot values. You could consider this a potentially O of 1 operation because cur map is going to have at maximum 26. So this would be equal to O of 26, which is equal to O of 1. So actually we kind of get this for free. I don't like the solution, but after spending some time, it's the best I could come up with right now. Nothing else immediately stands out to me. Alright, so I want to do a few things within the sliding window. Cur left is equal to chosen car map SL. Actually, first let's check if SL is equal to the chosen letter, because if it is, then chosen count is 1. Again, I don't know if this is necessary. I think this might become redundant in a few seconds. Regardless, let's check. Cur map is equal to SL. Cur left is equal to equals 1, and then we have to do re-choose the chosen count. Yeah, so I don't think this whole chosen letter stuff is necessary. Which means I might need to refactor this in a minute. Okay. Max of values. Size is equal to max of max size, and then also our current window. Current max size. I don't think it's necessary to refactor this right now. Yeah, it's not necessary to refactor this right now, but yeah, you can see I got this wrong quite a bit of times when I first attempted this problem. I'm happy with my solution. I think this is good. perfect? Of course not. But these two, oh, actually these are pretty similar. Okay, I'm gonna do some more analysis on this and then in the video here.